Hello everyone, this is Akanksha from Sri Venkateshwara College of Engineering, belongs to Department of Computer Science and Engineering, second semester, varying USN 1VE22CS092. Today I am discussing about the topic four-stroke diesel engine in the mechanical engineering. Here we can see the picture of four-stroke diesel engine and there are different types of strokes in this diesel engine. Here, the working principle of a four-stroke diesel engine is based on theoretical diesel cycle. Hence, it is also known as diesel cycle engine. There are four strokes in the four-stroke diesel engine. There are suction stroke, compression stroke, power stroke, and it is also called as expansion stroke, and it is also known as working stroke. And the last one is the exhaust stroke. The first one is the suction stroke in the diesel engine. Let us discuss about the suction stroke. In the case of diesel engine, during suction stroke, pure air is drawn by the piston. This air is compressed at the end of the compression stroke. Fuel is injected in the cylinder. On the other side, in the case of petrol engines, the mixture of air and fuel is drawn during suction stroke. At the beginning of the stroke, piston is in TDC, and during the stroke, piston moves from TDC to BDC. During this stroke, the inlet valve opens and the exhaust valve will be closed. The downward movement of the piston creates suction in the cylinder, and as a result, fresh air is drawn into the cylinder through the inlet valve. When the piston reaches the BDC, the suction stroke completes, represented by the line AB on PV diagram. Here we can see the picture of suction stroke and how it works, and this is the graph plotted between the volume and the pressure. In this diagram we can observe there are different parts like fresh air, fuel injector, TDC, piston, cylinder, BDC, connecting rod, crank and crankshaft. Here the TDC means top dead center is traditionally the position of an internal combustion engine's piston when it is at the very top of this stroke, and the BDC means the bottom dead center is the opposite when the piston is at the very bottom of its stroke. So in this graph, the AB is known as the suction of air and petrol, and it is plotted in the graph and it is named as A and B. And the second one is the compression stroke in the four-stroke diesel engine. During this stroke, the compression of fresh drawn charge takes place by the return stroke, that means from VTC to TDC of piston. During this stroke, both inlet and exhaust valves are closed. As the piston moves upwards, the air-petrol mixture in the cylinder is compressed adiabatically. The pressure and the temperature of the charge increases, and this is shown by the curve BC on the PV diagram. When the piston reaches the TDC or just before the completion of compression stroke, the spark plug ignites the charge. The combustion of the fuel takes place at the constant volume and is shown by a line CD on the PV diagram. The compression ratio in petrol engines ranges from 7:1 to 11:1, and the working principle of the compression stroke is bar. Here we can see the diagram of compression stroke and how it works. In it, fuel is ignited by heat generated during the compression of air in the combustion chamber, into which fuel is then injected. Hence, diesel engines are called compression ignition engines. A diesel cycle consists of one constant pressure, one constant volume and two isentropic processes. Here, this is the graph plotted between the volume and the pressure. So, in this, the line from B to C is known as the compression of mixture. And here in the compression stroke, you can see the inlet valve, exhaust valve, TDC and the BDC. And the third one is the power stroke, and it is also called as expansion stroke and also working stroke. At the beginning of the stroke, piston is in TDC, and during the stroke, piston moves from PDC to BDC. During this stroke, both inlet and exhaust valves remain closed. The combustion of fuel liberates gases, and these gases start expanding due to expansion. The hot gases exert a large force on the piston, and as a result, the piston is pushed from TDC to BDC. The power impulse is transmitted down through the position to the crankshaft through the connecting rod. This causes crankshaft to rotate at high speeds. Thus, work is obtained in this stroke. Hence, this stroke is also working stroke. Also, gas expands and does work on the piston. So, this stroke is called as an expansion stroke. The expansion of gases is adiabatic in nature, and this is shown by the curve dE on PV diagram. As the piston reaches the BDC, the exhaust valve opens. A part of the burnt gases escape through exhaust valve out of the cylinder due to their own expansion. And this is how the expansion stroke works, and the graph is plotted between the volume and pressure. In this graph, dE is known as expansion stroke. And the last one is the exhaust stroke. At the beginning of the stroke, piston is in BDC, and during this stroke, piston moves from BDC to TDC. During this stroke, the inlet valve is closed and the exhaust valve is opened. As the piston moves upward, it forces the remaining burnt gases out the cylinder through the exhaust valve. This is shown by the line dA on PV diagram. When the piston reaches the TDC, the exhaust valve closes. This completes the cycle. In the next cycle, the piston which is at the TDC moves to BDC, thereby allowing fresh air to enter into the cylinder, and the process continues. This is how the exhaust stroke works, and the graph is plotted between volume and pressure. Here BA is known as the exhaust of combustion product, and this graph is plotted between the volume and the pressure. In this, AB is known as suction of pressure, BC defines as compression of air, CD refers to constant pressure combustion at D fuel supply cutoff, DE is the expansion stroke, EB is exhaust valve, BA is exhaust of combustion process. I hope you understood about full stroke diesel engine. Thanks for watching.